Hey everybody, if you're watching this video, you want an explanation as to why change of base works. And I'm going to explain that real quick to you as far as why we're using the change of base property and why that works to do log A over the log of B. Okay, we're going to explain why that actually makes sense. So we're going to use this example of 4 to the x equals 128. Now I can't just punch in my calculator. It's a little more difficult to try and figure out what exponent is by just multiplying 4 how many times and see what it is. If I were to try that, I know it's a little more than 3, but I want to see how exact I can make it. Okay. Now I can actually use logs to be able to figure out what this x value has to be. And I can do that by converting these into the same base and using the common base property that we did with our exponents. We're kind of bringing ourselves back to those properties. So I'm going to show you that. So we're going to basically do the log of 4 because that's going to convert it into 10 something, because log of 4 is saying it's the log base 10 of 4, what the output is to 4. Okay, same thing with the 128. We'll go log of 128, and what that'll give us is 10 to the something, and that'll be equivalent to what 128 is. Okay, so let's change those. So let's change those into all base 10 values. Okay, so if I go 10 to that means I have to do log of 4. Let's clear everything. So if I go log of 4, that gives me 0.6, that gives me this whole decimal. Let's just round it, try and keep it exact, but not too long. So let's go 0.6021, okay, to the 0.6021, okay, and that's still, remember I still have this exponent. So I just converted what 4 was. So this is what 4 is equivalent to in base 10. Let's set that equal to, and now let's do log of 128. And that's, let's call it 2.1072. .1072. Okay, so really I haven't done anything but made different looking value of 4 and a different looking value of 128. But the reason why this is useful is because now they're both in base 10, so I can use my common base property that I have for exponents. Okay, so I'm going to rewrite this so we kind of have everything in one spot. 0.6021x, right? Those can go together, equals 10 to the 2.1072. I have a common base, which means these have to be equivalent. So I can write 0.6021x equals 2.1072. Hopefully you can see the algebra with this. Divide by 0.626021. Okay, and then I'll get x by itself, and that's ultimately what I'm trying to find. And let's do that really quick here. So that means if I go 2.1072 divided by 0.6021, I get really, really close to 3.5. Okay, about. Okay, well, let's look at what this actually means. If this is, so if I look at this part especially, all that means is this 2.1072, well, that was just log of 128. And log of 4, well, that was just that 0.6021, which means that if I just take the log of A here and the log of B, I can get my end result, which is right around 3.5. Okay, so let's try that. If we just do that, log of 128 divided by log of 4, 3.5. Look at that. Okay, that's the basis for change of base, where instead of having to do all of this work, I can simply just take my log of A, log of B, and I can get what I need. Hopefully that's a better explanation, guys. I hope you have a great day, and we'll see you on the next video.